We have two data sets, train data set and the station data sets. It's a trip data set. On the two data sets, we are constructing the graph and performing these analyses. Triangle count, shortest path, page rank algorithm on the graph, and then we are saving the graph to the file, and then we are applying a label propagation algorithm and BFS algorithm for the bonus questions. Now let's quickly go to the code. Here we have two data sets, trip data sets, which is a CSV files where we are loading this file and storing it in the trips data frame. Similarly, we have a stations data set, which is a CSV file, and we are loading this file into the station data frame. Here we are printing the schema for both the data frames, trips and station. To work on these two data frames, we are temporarily creating the views, trips and stations on these two data frames. And from this particular view, we are selecting all the columns and storing it in station, and then in trips select star from stations into station and select star from trips into trip. Now in the station vertices, we are renaming the column name to ID. Here the vertices or the graph vertices. So for the graph to give the vertices, we are selecting all the distinct vertices and renaming the column as ID. Similarly, from the trips, we are selecting the column start station, end station, and we are renaming it to source and destination and storing them in trip edges. Now we are building the graph using graph frame. Here it takes two parameters, vertices and trip edges. Vertices are nothing but the stations, trip edges are nothing but the routes which contain the source and destination stations. Here this is our graph. Now we have the graph here displaying all the vertices, all that is the stations, distinct stations, edges, nothing but the trips, distinct trips, and from the original data we are displaying the trips. Since the original data and graph data edges are same, we'll have the same count for the graph trips and original data trips. From the graph we are displaying the vertices and edges. Now comes the ICP task. Triangle count. Triangle count, it gives the number of triangles passing through each station, that is passing through each vertex in the graph. So we are running this particular algorithm on the graph, and we are displaying the count here. Similarly, we are performing the shortest path algorithm on the graph. Here the landmarks are Japantown and Santa Clara County Civic Center. Here the shortest path algorithm gives the shortest route from all the paths, from all the vertices, that is from all the stations to these landmarks. Here we're displaying the output of the shortest path algorithm. Here we're calculating the page rank. On the graph we are applying page rank with reset probability of 0.15 and tolerance of 0.01. Here the page rank gives the rank of each vertex and the weight of each edge in the graph. Here the page rank, we can say the likelihood of vertex to be visited compared to other vertices in the graph. And then we are saving the graph vertices and edges in this particular folder. Here for the bonus question, we are applying label propagation and BFS algorithms on the graph. Label propagation, it labels the vertices in the graph, that is while traversing. Here we gave the iterations 5, it traverses the entire graph 5 times and assigns label to each vertex, that is vertex with same label are treated as one community. Here we are displaying the ID and label of that output algorithm, and similarly we are applying BFS with the start node as Japantown and to expression dog count less than 15. Now the BFS, that is the breadth first search starts from this particular vertex, that is Japantown, and we are displaying the output of path BFS. I have already run the program, so let's see the output. Here this is the schema of Schema of two data frames is the trip data frame which has start station and end station, and this is the schema of stations data frame which has the station name and station ID. Here we are displaying the number of stations from the graph. Since the original data and graph data are on the same data, we have same number of trips, that is same number of edges in both the data. Here we'll go to our ICP, the triangle count. Now here you can see the stations here and the triangles, count of triangles passing through each station. Here there is a count. Next comes the shortest path. Here we have the shortest path from each station to Japantown and Santa Clara County. Here this is the distance, this is a map route from this particular station to the landmark destinations. Next comes the page rank. Here we have a page rank algorithm performed. The page rank here we're displaying for vertices as well as the edges. Here this is for the vertex, so each vertex and the page rank. So here you can see this has highest page rank, so California Avenue is likely to be visited more compared to the other vertices, we can say that. Similarly, we have the page rank for the edges, that is trips. Here the weight of each trip is displayed over here. Similarly, we performed the bonus question, the label propagation. Here you can see each station is assigned a label over here. So you can say MLK library and Adobe have same labels, so they come under same community. Similarly, the 64th, these three stations come under same community. Here is the BFS. Here the breadth first search is started at this particular vertex Japantown over here. Since the output is lengthy, it's only displaying the 20 rows. This is all about this particular ICP.